In a high-security wildlife reserve deep in the northern Rockies, a sound echoed across the crisp dawn air, a howl, ancient yet new. It was not from a gray wolf nor a coyote. This was deeper, fuller, resonating with the memory of a lost world. It came from a creature that had not walked the earth since the last ice age. It was the voice of a dire wolf, reborn 10,000 years after its extinction. The animal's powerful frame, thicker boned than a modern wolf, its eyes glowing amber in the morning light, was a symbol of both ancient majesty and cutting-edge science. The team at Colossal Biosciences, led by geneticists, conservationists, and engineers, had done the unthinkable. They had brought the dire wolf back to life. But before we marvel at its resurrection, we must first understand what was lost. The beast of the Ice Age. The dire wolf was no myth. Long before humans ruled the land, this beast reigned as one of the most formidable predators of the late Pleistocene epoch. Between 250,000 to 10,000 years ago, it prowled the wild terrains of North and South America, from the icy stretches of what is now Alaska to the humid jungles and swamps of ancient Peru. The dire wolf was not simply a larger version of the modern gray wolf, it was a formidable predator in its own right. Weighing in at over 150 pounds, the dire wolf boasted a muscular, stocky frame, far bulkier than that of its modern counterpart. Its jaws were massive, capable of exerting crushing pressure on its prey. With strong neck muscles designed for gripping and tearing, the dire wolf could easily snap bones and rip through tough hide with terrifying ease. This was no average hunter. Its physical power made it a top predator of the Ice Age, able to take down prey far larger than itself, such as giant bison and even young mammoths. Its intimidating presence in the wild was enough to strike fear into any creature unlucky enough to be within its reach. When the dire wolf roamed the earth, it was truly a force to be reckoned with. And unlike many modern-day predators, dire wolves were pack hunters. They worked together with chilling precision, bringing down prehistoric megafauna, giant bison, camels, ground sloths, and even baby mammoths. Their cooperation, combined with brute force, made them one of the most efficient killing machines of the Ice Age. But dire wolves weren't built for forever. They thrived in a cold, harsh world, surrounded by massive prey and open landscapes. As the Ice Age melted away, the world transformed. Forests spread, temperatures rose, and one by one, their prey disappeared. The dire wolf, perfectly adapted to a dying environment, had no place in this new era. Yet today, 10,000 years later, that story is taking a wild turn. Thanks to cutting-edge science and ancient DNA, the dire wolf may be about to rise again. The last howl of dire wolf. Roughly 10,000 years ago, the reign of the dire wolf came to a sudden and silent end. For hundreds of thousands of years, these apex predators thrived in the sprawling grasslands of the Ice Age, hunting massive herbivores alongside saber-toothed cats and short-faced bears. But as the Pleistocene epoch drew to a close, everything began to shift. Temperatures rose, glaciers melted. The world that had once been ruled by giants was disappearing, fast. The lush grasslands turned into dense forests, and the cold, open environments that dire wolves dominated were no more. Their prey, the massive bison, giant sloths, ancient camels, and juvenile mammoths, began to vanish. Climate change was a brutal force, but it wasn't acting alone. A new predator had entered the arena: humans. Homo sapiens, migrating into the Americas from Asia, brought more than just weapons. They brought strategy, adaptability, and a social structure that rivaled even the dire wolves' pack dynamics. Armed with sophisticated hunting tools and the ability to coordinate attacks, humans began competing directly for the same prey. And they were winning. The dire wolf, built for power and specialized for hunting megafauna, couldn't adjust. Its powerful jaws, once an advantage, became a disadvantage when smaller, quicker prey became the norm. Unlike the gray wolf, which evolved to scavenge and diversify its diet, the dire wolf was trapped by its own design. Slowly, but surely, the once great predator faded. Not with a dramatic final battle, but with a whisper. And for centuries, we believed that was the end of the dire wolf story. No fossils after a certain point. No descendants, just gone. But today, 10,000 years later, the winds are shifting again. Because what if extinction wasn't forever? Enter the 21st century. In a world where technology advances by the second, a small group of scientists asked a bold question. Could we bring back extinct species? That question became the mission of Colossal Biosciences, a Texas-based biotech startup co-founded by visionary entrepreneur Ben Lamb and Harvard geneticist Dr. George Church. Their team was already working on reviving the woolly mammoth to restore tundra ecosystems. But soon, their attention turned to another Ice Age icon, the dire wolf. Unlike dinosaurs, which are far too old for DNA to survive, dire wolves left behind fossils with recoverable genetic material. In 2022, scientists recovered DNA from a remarkably preserved dire wolf bone found in Nevada, buried in permafrost. Though degraded, this ancient DNA held the secrets of the animal's biology. With advanced CRISPR gene editing tools and synthetic biology, Colossal began piecing together the dire wolf genome. Because the DNA was incomplete, they compared it with modern wolf and dog genomes to fill in gaps. The result? A viable embryo containing reconstructed dire wolf traits. Using a surrogate gray wolf mother, the first genetically engineered dire wolf was born in a secure facility in 2027. It looked similar to a gray wolf, but broader in the chest, more powerful in the limbs, and carried an instinctive behavioral code from a world it had never known. Why science wants the dire wolf back? Naturally, not everyone cheered when news broke that scientists were working to resurrect the dire wolf. Critics and conservationists alike raised an uncomfortable question. Why bring back an extinct predator when we're already struggling to save the species we have? Dr. Elena Ruiz, lead researcher of Colossal Biosciences' Dire Wolf Initiative, didn't shy away from the controversy. In fact, she welcomed it. The dire wolf isn't just a creature of the past, she explained. It's a living key, a window into how ecosystems functioned before modern human interference. If we can understand how the dire wolf lived, we might understand what we've lost and what we could bring back. And that's the heart of the mission. Bringing back the dire wolf isn't just about curiosity. It's about science, conservation, and restoration. From a scientific perspective, reviving a species lost for 10,000 years allows researchers to explore genetics, adaptation, and evolution like never before. How did this predator survive the Ice Age? Why didn't it adapt? The answers could shape how we protect species today. But it goes further. The gene editing technologies developed to bring the dire wolf back could help revive endangered animals, improve genetic diversity in small populations, or even restore extinct plant species crucial to the food chain. Then there's the environment itself. Just as reintroducing wolves to Yellowstone National Park helped rebalance the ecosystem, scientists believe dire wolves could help restore overpopulated regions and curb ecological imbalances. So maybe this isn't just about reviving a predator. Maybe it's about giving nature a second chance. Today, in the wide, wind-swept grasslands of Montana, a once extinct predator is walking the earth again. The newly engineered dire wolves, brought back to life through cutting-edge genetic science, now roam a vast 20,000-acre reserve designed to simulate their ancient environment as closely as possible. This controlled wilderness is carefully managed to reduce human interference while still allowing close monitoring. Drones silently hover overhead, while high-definition cameras hidden in the brush capture every movement. Biometric tags track vital signs and movement patterns, feeding scientists a steady stream of data. But most remarkable of all is how little guidance these animals seem to need. They are not gray wolves, says Dr. Jaya Thompson, a behavioral ecologist on the project. They don't move like them. Their gait is heavier, their posture more calculated, their bite pressure is immense, far beyond that of any living wolf. These animals weren't built just to survive. They were built to conquer. The dire wolves have surprised researchers with their deep-rooted instincts. Despite being born in the 21st century, their behavior mirrors what scientists expected from fossil evidence: pack formation, coordinated hunts, territorial markings, and complex vocal communication. Yet, this is not a world of mammoths and megafauna. These wolves are learning to hunt modern prey, deer, elk, and wild cattle, adjusting their strategies in real time. It's a blend of the ancient and the new. Ice Age genetics meeting a post-industrial planet. How well they adapt, socially, biologically, and ecologically, will determine what comes next. For now, they are thriving in their carefully crafted domain. But the ultimate goal is far more ambitious: a return to the wild. Whether that becomes reality depends on what they do next. The Dire Wolf Project has already proven to be a groundbreaking success, reshaping how we think about extinction, genetics, and the balance of ecosystems. It's teaching us that extinction may not always be final. With the right genetic tools and enough preserved DNA, what was once thought to be irreversible is now within the realm of possibility. This opens the door to the idea that perhaps other long-lost species might one day return. Beyond just resurrecting an ancient predator, the project is showing how ancient DNA can provide insights into modern science, particularly in fields like virology and genetic disorders. Understanding the immune systems of Ice Age creatures could lead to new ways of tackling diseases and improving disease resistance in humans. Equally important is the ecological lesson the project imparts. Ecosystems need predators. The absence of apex predators like the dire wolf has led to imbalances in various ecosystems such as overgrazing and the spread of disease in prey populations. This has profound implications for wildlife conservation today. Perhaps most crucially, the dire wolf reminds us that we, as humans, are not just the caretakers of the present, but the stewards of the planet's entire legacy, past, present, and future. The story of the dire wolf is a lesson in the power of science, the responsibility we hold, and the possibility of redemption for our planet. The future of the dire wolf. So, what now? Will these creatures be released into the wild? Will they roam forests and mountains freely once again? Not yet. Colossal's current plan is measured and gradual. They aim to expand the reserve network and eventually test deer-wolf interactions in broader, semi-wild environments. The goal is not to flood ecosystems with predators, but to rebuild select regions that could benefit from their presence. In the long term, Colossal Biosciences has a bold vision for the future of the dire wolf and the broader field of de-extinction. One of the most exciting possibilities is the idea of hybrid pack integration. By testing the cohabitation of revived dire wolves with gray wolves, scientists aim to observe the potential for social blending between the two species. This would not only shed light on how the dire wolf's social structure functioned, but also provide valuable insights into interspecies dynamics in the wild. Another ambitious goal is to use the Dire Wolf Project to support the revival of megafauna. Colossal envisions creating fully functional predator-prey ecosystems with creatures like the woolly mammoth and ancient bison, animals that once roamed alongside the dire wolf. Such ecosystems could help restore lost ecological balance, bringing back critical interactions that have been absent for millennia. Beyond science, Colossal is focused on education and tourism. The Dire Wolf Project offers a unique opportunity to engage the public in ecological history, evolution, and genetic science. Visitors to the reserve could learn firsthand about the power of genetic engineering and the complexities of ecological restoration. Yet, there are still many challenges ahead. The ecological risks, ethical debates, and unknowns of reintroducing an extinct species into a world that has dramatically changed are not lost on Colossal. However, the company remains hopeful that by reviving the past, we can shape a more sustainable future. At the end of the day, the return of the dire wolf is more than a scientific marvel. It's a message. We once stood by as species vanished, thinking extinction was forever. But with knowledge comes responsibility. As we race into a future shaped by climate change, collapsing ecosystems, and genetic innovation, the dire wolf is a living symbol of what can be lost and what might be restored. Under the silver moon, in a world shaped by human hands, the howl of a creature once silenced for 10,000 years now echoes again, clear, primal, and alive.